So here I have a 212cc go-kart engine that I've had for way too long. It's kind of obviously been collecting rust and whatnot, so basically the intent of this project is to apply torque fundamentals with this Husky torque wrench to break loose all the bolts. And my intention with this is to be able to strip this thing down, starting with these head bolts that are thoroughly stuck, and be able to eventually break this thing down and see if I can buy parts and get it running again. So to start off, I'm going to use this penetrating catalyst called PB Blaster to get inside the threads and hopefully loosen them up. What this is going to do is penetrate beyond the bolt head, get into the threads, and hopefully break up some of the corrosion and oxidation that has occurred within that thread, and hopefully I can break it loose. Let's see how it works. Let me let that sit for a little bit and I'll whip out the torque wrench. So here I'm going to set the torque wrench to 50 foot-pounds. As you can see, that is now at 50 foot-pounds, and I'm going to attempt to break loose this head bolt that is very seized. Let's see if 50 foot-pounds will do the trick. Oh, look at that, it got it. Probably should have started a little lower. That didn't work. I'm going to move on to this second head bolt, but first I need to remove this exhaust manifold. So let me start with some PB Blaster, because this one is, as you can see, very corroded. Let that sit and do its thing for a little bit. And I'm impatient, so I'm going to start. Let's try and do... This is very difficult to do with one hand. Let's try this out with 40 foot-pounds this time. So 40 foot-pounds. Alright, let's give it a shot. And it was already loose. Alright. Let's drop that down for the other one. Let me just set this and then I will start the video again. I think I'm going to do 20 foot-pounds. So as you can see, we're at 20 foot-pounds. A little bit off. Man. So as you can see, we're at 20 foot-pounds. Just a little disclaimer, this torque wrench was recently calibrated. Let's see if 20 foot-pounds can break this. Once again, no problem. Alright, let me pull this off. Let me do this myself, and then the next video will be breaking loose that bolt. Interestingly enough, the thread hanging this exhaust manifold on is actually a double-sided thread. This one pulled from the top of the header. As you can see, there's two different reversing threads there. Or not reversing, they're the same direction, but there's two threads there. So it pulled there, so this is frozen. And here, it pulled directly from the top of the thread. Interesting. Alright, let's try this again. This has been soaking in PB Blaster for probably about the last 5 minutes. Now let's see if we can break it. I have the torque wrench set to 20 foot-pounds. Let's give this a shot. Oh, 20 foot-pounds is gonna cut it. So I'm gonna bump it up to, okay, so 20 foot-pounds did not work. So I'm going to put this at 25. Let's see how it does. And it clicked, but it broke, so it took about 25. Let's pull all these off, and we're going to have to get up under the valve cover for the other two. So just while I'm pulling these head bolts out, I noticed something that would relate to all the materials we've learned in this class. It appears as though this whole valve cover, this header, and even the actual cylinder core or assembly, whatever you would like to call it, is a cast aluminum part. You can kind of just tell by the color and the surface finish and all this oxidation that has occurred, which would indicate that it is in fact aluminum. And these header bolts appear to be galvanized steel. And I can just kind of tell from experience, based on how this metal is oxidized and pitted, that it is in fact a zinc-coated galvanized steel bolt. So just something interesting there. So when I went to pull this valve cover off to access the header bolts, I noticed that this is very frozen. It appears as though the gasket is kind of welded to this, so therefore I'm going to use my handy pry bar, aka flathead screwdriver. Being safe, of course, because who knows what this will do. And my improvised hammer. Let's see if we can get this off. There she goes. And here we have the valve assembly, your springs, your lifters, rocker arms, whatnot. And buried back behind that, you can see the other end of the header bolts. So let's get those pulled off, and we will see how much torque those need. Probably not as much, due to the fact that they are not corroded because they were sealed within this valve cover. And it looks like I just destroyed that whole gasket. But that is all good. I'll replace it. And let's get at it. So let me grab my 12mm socket here and throw it on the torque wrench with this little extender. I'm going to set this, because I don't believe that these bolts are very locked up, to, I'm thinking 15. Let's see how 15 will work. I'm going to start with this right one. Sneak around the valve here, valve rocker, and I'm on. let's see how this works. Oh. And click. So we need a little more torque. Let's try 20. Oh, and 20 did it. So somewhere there between 20 and 15. 15 and 20. Alright, now that we know that, let's try this other side. However, I'm going to dial this in to, let's go to, that would be 19. I'm going to start at 17. Let's see if that's enough breakaway. And click. Oh. Click, and then it broke. So let's call this somewhere between 15 and 17. Average it 16. Okay. Now let me pull these off and we'll get a nice little peek inside the cylinder. Okay, so those bolts are pulled out about as much as I can get them without pulling the whole head off. There's one more bolt on the side, this little strap that's going to hold me on here. So let me get that off. And once that is off, voila. Now, this is a surprise for me. Check out all that corrosion. Wow. And that is what happens when you leave the spark plug off and let your go-kart engine sit in your backyard for about 3 years. That is an impressive amount of corrosion there. I mean, I cannot even see the cylinder walls, it's so bad. Wow. That is some oxidized iron. So if you look here, it appears that they used a steel jacket within the iron, or the, I'm sorry, cast aluminum cylinder housing. Interesting. And it appears as though this is all one solid piece that has been fused together. Here's my valve lifters. So, lesson learned on this one: don't leave your engine open to the elements. And I need to go clean my hands. Still turns, not sure how. Yeah, it'll buff out. I noticed in here is when I turn the shaft, it appears as though the corrosion has built up to a point where I cannot even complete an entire power stroke. I get about maybe 90 degrees. Yeah, about 90 degrees. So let's see what I can do about this, but this engine might have to go to the scrapyard and the parts bin. Just PB blaster it. See if I can free it up a little bit. degrees. So let me go to the bottom of the stroke, very bottom. I'm just gonna let that sit, see what it can eat up. Lesson learned here, don't leave the spark plug out for 3 years while your engine sits. So I've now let this sit for about 2 or 3 minutes. Seeing a little bit of progress, but some of the corrosion is so deep set that I'm gonna try to remove it with a brass brush. Now, I also have a steel brush. However, steel, based on the table I just looked up, can range from a Mohs hardness of 5 to 8.5. And because this is a hardened, likely high carbon steel jacket based on all of the corrosion in here, if I were to use this brush and these bristles were a higher Mohs hardness, I would risk scratching the cylinder walls, which would lead to compression losses, which would lead to inefficiency within the internal combustion of the engine. You'd have leaking into the crankcase. It would be no good. Therefore, I'm going to attempt to use this brass brush, Mohs hardness 3 to 4, in an attempt to remove just the iron oxide, aka rust, from the cylinder walls, in an attempt to smooth these out without scratching the steel sleeve in which this cylinder is encased in, thereby smoothing the surface finish of it, reducing friction, reducing efficiency losses due to hot escape gases coming through the piston rings into the crankcase, which is just an entire loss of everything that you're trying to accomplish with a internal combustion engine. So it appears as though, and this might be somewhat difficult to see, but it appears as though this is working just how I thought it would. Now, it appears on camera to be scratched, but really it's just the way that I'm brushing it. But I do not see any scratches caused by this brass brush. Therefore, it appears we are only removing the iron oxide from the surface of the cylinder wall. Now I'm going to continue doing this and see if this will allow me to get a full 360 degrees of stroke and therefore salvage this engine, which when I pulled the header off I thought was a total waste of time. So let's see what happens and we'll take a look in the next video. So I just scrubbed this for, I don't know, 3-4 minutes, and I'm going to remove the PV blaster I used. It appears that we are making pretty good progress here, and let's see just what all that work did. As we can see, the surface finish up in here has vastly improved. It appears that up there we might need some work. But down here, although we do have some minor corrosion still, it appears that we are getting a little better. So let's see how those piston rings can slide past. So before we had about from here to here in our stroke. Here to here. Now I can go down a little more, which down a little more gets us to almost the top. If I really want to muscle it, it appears as though I can get almost all the way to the top of that power stroke. And it looks like it left us a little debris there, which I will clean up. Let's see. Almost. So we can go all the way to the bottom of this. Oh, there we go. Ladies and gentlemen, she is free. That's a full 360 spin if I've ever seen one. So to sum this up, the lesson learned here was apply the correct torque to the bolts. Don't over torque to break them loose, because this little hour-long project could have turned into a week-long project had I snapped one of those bolts in the cylinder head. So then we removed the valve cover, which still needs a little bit of work. We found very little corrosion in there. Found that those bolts that sat right there were perfectly fine. They broke at about, say, 16 or 17 pound-foot. These broke a lot higher than that due to being exposed to the elements. And when one wants to let an engine sit for 2-3 years, definitely make sure to reinsert and torque down the spark plug so that we don't see this atrocity happen again, to where the motor seizes up due to corrosion due to rainwater filling the cylinder. And there you go. We have almost an entire, well, we do have an entire power and intake stroke. So right here, if we're going to start from the start of the strokes, due to the fact that this is a 4-stroke engine, we see this is your intake, so your suck. Get to the bottom of the stroke, then we have our compression, our squeeze. Top of the stroke, we have our bang, which is our power stroke. Get to the bottom, squeeze all the power out of that. And then we have our exhaust stroke, our blow. So let's see if we can get this thing running. And first I gotta make sure I have all the parts.